Hi, my name is Sanjana Kadia, and I modeled the use of capacitive deionization, or CDI, to remove contaminants such as bacteria, viruses, and heavy metals from water. Fresh water is becoming increasingly scarce, and drinking water is becoming less affordable, largely due to increasing water treatment costs, which prompted me to look for innovative alternatives. A potential solution I found is capacitive deionization. CDI is a device which uses a charging voltage to create an electric field in the water to remove contaminants by absorbing them onto their oppositely charged electrode. Benefits of CDI is that it is highly cost-efficient, energy efficient, as it requires a very low charging voltage, and versatile, as it can remove a variety of contaminants. So far, CDI had been proven successful in desalination setups and removing heavy metals, but I posed a question whether it could be used to remove other types of charged contaminants, such as bacteria and viruses. And I also wanted to see, since CDI required such a low charging voltage, whether it could operate under a renewable energy setup. To address this, I created simulations based on the relationship of forces within the CDI cell. The movement of the contaminant was dependent on the electric field. So I related the force of Newton's second law, the force of mass times acceleration, to the Lorentz force, the force of the electric field, which is force equals charge times voltage over distance. Using this model, acceleration could be solved for, which then allowed me to solve for time removal. The removal of the following contaminants was observed in this study: E. coli bacteria, coronavirus, and lead. The time removal efficiencies of CDI for the following contaminants were all under 1 second, which meant that each contaminant was successfully removed under the simulation before exiting the CDI cell. The previously stated method was under idealized conditions, so I also wanted to introduce non-idealized parameters such as pH and temperature, which can cause fluctuations in charge as well as fluctuations in how well the contaminant could adsorb onto its electrode. Although some fluctuations were observed, neither factor was significant enough in preventing the contaminants from being removed from the water. To show proof of concept that CDI could operate under a renewable energy setup, I tested solar cells over a 10-hour period, and these solar cells showed a sustainable voltage of 1.6 volts, which was sufficient to power the CDI cell without the use of any external power sources. Clearly, CDI holds great promise to serve as a viable water technology as shown by the study, and I look forward to converting my models into an experimental setup in the future. Thank you so much for listening.